Accurate measurement of blood glucose levels is essential for the effective management of diabetes mellitus, a chronic condition affecting millions worldwide. So glucometers or blood glucose meters are portable devices that are widely used by the patients and the healthcare professionals to monitor the glucose levels in real time. However, the reliability of these readings depends heavily on the accuracy and the precision of the device. Therefore, evaluating the accuracy of a glucometer is a critical step in ensuring it meets the established clinical standards, such as those outlined by the International Organization for Standardization. This process involves comparing the glucometer's result with reference laboratory methods to assess its performance under various physiological and environmental conditions. A thorough accuracy evaluation not only supports safe and effective patient self-monitoring, but also contributes to improved therapeutic outcomes and reduce risk of complications associated with poor glycemic control.
Now, I will explain the theory parts of our experiment. In this experiment, we apply two key statistical concepts, the Q-test and the confidence level. Firstly, the Q-test is used to detect outliers in the set of data. If one of the glucose reading is noticeably different from the others, the Q-test helps us determine whether that value should be rejected. This helps improve the reliability of our data when evaluating the accuracy of the glucometer. Next, the confidence level represents how certain we are that the true values lies within a specific range. For example, using a 95% confidence level means we are 95% confident that the actual glucose concentration falls within that calculated interval. Therefore, by using the Q-test and confidence level, we can assess how accurate and consistent the glucometer is in measuring blood glucose level.
And these are the objectives of our experiment on accuracy evaluation of a glucometer. The first one is to identify normal and abnormal ranges of blood glucose levels. The second one is to demonstrate the proper use of a glucometer for measuring blood glucose levels. The third one is to identify possible measurements errors in the glucometer through data evaluation using the Q-test. And the last one is to calculate the confidence level of glucose measurements to assess data reliability.
There are 6 apparatus involved. The first one is the alcohol swab. It is used to sanitize the fingertips before collecting the blood. The second one is sterile lancet. It is used to prick the fingertip to draw drops of blood. The third one is glucometer, the blood glucose meter. And the fourth one is test strip. We use test strip that is compatible with the glucometer, and we also use cotton ball to stop the bleeding. And lastly, we use gloves to maintain the hygiene and safety.
Okay, let's go through the step. Check blood glucose using a glucometer. Step 1. Prepare the material. First, make sure the glucometer is functioning properly and that the test strip is ready. Step 2. Clean the fingertip. Then use an alcohol swab to clean the side of the fingertip, usually during our middle finger. So let it dry completely to avoid the interfering with the reading. Step 3. Prick the fingertip. Next, take a sterile lancet and prick the side of the fingertip gently. Step 4. Obtain a drop of blood. After pricking, gently squeeze the finger to get a drop of blood, but don't press too hard. Step 5. Apply blood to test strip. Now, place the drop of blood onto the test strip that's already inserted into the glucometer. Step 6. Wait for the reading. Wait a few seconds. The glucometer will process the blood and display the glucose level, usually within 5 to 10 seconds. Step 7. Stop the bleeding. After that, press the fingertip with a cotton ball or tissue to stop the bleeding. Step 8. Record the result. And finally, write down the glucose reading along with the time. This helps in tracking and monitoring your level over time. So, this is label pictures of the setup of the experiment that we do for blood glucose test.
This is the simulated result for our experiment. In this simulation, the blood glucose data was assumed to be collected from multiple patients as part of a clinical trial, where the goal is to evaluate the accuracy and reliability of a glucometer device. We recorded 10 glucose readings in millimole per liter and included additional information such as age, sleep hour, and whether the person ate before the test, since this factor can affect blood glucose level.
Okay, so now moving on to the discussion part of our project. This data was taken part of a clinical test, not to monitor a patient, but to evaluate the reliability of the glucometer. From the data we got, we suspected there was a possible outlier. To decide what to do with the suspicious value, we applied the Q-test, and also the consequence calculation, which is confidence level, that proposed to estimate the range of the true blood glucose level within the groups. But first of all, let's take a look on the Q-test steps. First, we need to arrange all the data in increasing order. Second, find the gap between the data and the range of the data. Third, determine the outlier which have the highest gap between the data. Fourth, calculate the Q experiment using formula A over W in modulus. Determine the Q table based on the critical value of the rejection quotient Q table. In these tables, we need to take a look on the 95% confidence level for this case, because it is commonly used in medical research. Next, compare the value of the Q experiment and Q table. If the Q experiment is more than Q table, the outlier has to be rejected. But if the Q experiment is less than Q table, the outlier has to be retained. Lastly, the conclusion. Next, confidence level steps. First, find the mean and the standard deviation. Read the t value based on the values of t for various level of probability table. On this table, we take a look on the 95% confidence level column only, as I say is commonly used in medical research. And then find the confidence level or mu using this formula. Lastly, the conclusions. So confidence level gives us more reliability of the glucometer readings after the Q test. Next, let's apply it in our data. So as you can see, we already find the range, which is 5.6, and the gap is 3.0, which is the highest gap. And that indicates the outlier, which is 10.3. The Q experiments that we got is 0.5357, and the Q table is 0.5660, which indicates the Q experiment is more than Q table, that cause the outlier will be rejected. So thus, this might be due to the error of the glucometer that caused the blood glucose of the patient is different from the others. Next is confidence level, and we already calculate the mean, which is 5.71, and we did tables for reference of standard deviations, and we got 0.889. After we calculate mean, standard deviation, and also the t value, let's apply it in the formula that gives us two values, which is for the upper and the lower. As for the upper value, we got 6.395, and lower is 5.025. Hence, with 95% confidence level, the true blood glucose level is within 5.025 to 6.395. This experiment also, we use the clinical reference range, which is the normal and abnormal blood glucose, when for normal fasting blood glucose, its level usually between 4.0 to 5.9 millimole per liter. But after eating, it can go up to 7.8 millimole per liter. Since our confidence interval lies between 5.05 and 6.395 millimole per liter, it fits within the normal range. But the 10.3 reading was way too high, and based on our analysis, it was an error of the instrument, but not a real condition. As I say, it's an instrument error, where the glucometer process needs improvement to prevent the inaccurate result like this in real life. We need to make sure there's no contamination and that the glucometer is properly calibrated. Even small things like not washing hands using test strips or a dirty device could lead to errors, which is what we identify here.
In conclusion, the study successfully achieved its intended objectives. The glucometer was used to measure blood glucose concentrations and distinguish between normal and abnormal values among individuals. The procedure also demonstrated the correct method of using a glucometer effectively. Through statistical analysis using the Q-test, a potential outlier was identified and rejected, highlighting the possibility of measurement errors. Lastly, the confidence level was calculated to evaluate the reliability of the glucometer readings. This shows that the glucometer is generally reliable, but occasional errors such as improper handling or device inaccuracy can occur and must be considered.